Alright, so for the next set of problems, we're going to be using the distance formula, right? So we have the square root x2 minus x1 squared plus y2 minus y1 squared. And we know that because we're trying to find the distance or the length between 2 points. And this formula, you need the points. Okay? So, square root, I'll make this x1, y1 and this x2, y2. So 2 minus negative 4 squared plus negative 5 minus 5 squared. So that's the square root of 6 squared plus negative 10 squared. Make sure everything's in parentheses. That's the square root of 36 plus 100. The square root of 136. Alright. So 136 can be broken down into 2 times, let me think, 68. 68 is 2 times 34. And 34 is 2 times 17. So what we really have is the square root of 2 times 2 times 2 times 17. Cross, for every two things that are the same that you cross out, you bring one out front. So that's all I can bring out. So my answer is 2 square root, and then I have to recombine this 2 times 17 into the square root of 34. So 2 square root of 34. Okay? Just get my calculator out for a second here. I also want to show you that if I did the square root of 136, I get that for an answer. Now if I do 2 square root of 34, I get the same thing. See? Okay. Next problem. 60. Same deal. Square root x2 minus x1 squared plus y2 minus y1 squared. Let's say this is x1, y1, x2, y2. 1 minus negative 3 squared plus 0 minus 2 squared. That's 4 squared plus negative 2 squared. So that's 16 plus 4, that's the square root of 20. Now 20 can be broken down into 2 and 10 and 2 and 5. So the square root of 2 times 2 times 5. Cross out 2 2's, bring 1 out front. 2 square root of 5. Again, let's double check that. Square root of 20, 2 square root of 5, they're the same thing, okay? 61. x1, y1, x2, y2. x2 minus x1 squared plus y2 minus y1 squared. 146 minus negative 4 squared plus 52 minus 2 squared. And they want it to the nearest tenth, so I'm just going to plug that in directly. Square root. I'm adding another parenthesis, so 146 minus negative 4 squared plus 52 minus 2 squared, close again, enter. 158.1. Choice 4. Okay, x1, y1, x2, y2. x2 minus x1 squared plus y2 minus y1 squared. 2 minus negative 6 squared plus negative 5 minus 4 squared. 8 squared plus negative 9 squared. 64 plus 81. 145. Choice 4. Number 63. x1, y1. x2, y2. It's a circle with a diameter that has the endpoints. What's the length of the diameter? So it's the distance formula. Um, 3 minus negative 5 squared plus negative 6 minus 4 squared. 8 squared plus negative 10 squared. 64 plus 100. 164. 2 and 82. 2 and 41. So 2 times 2 times 41, because 41 is prime. 2 square root of 41. Let's check. Square root of 164. 2 square root of 41. Same thing. Okay, 64. Let me just sharpen. Oh, this one's good. Alright, so we got x1, y1, x2, y2. Choice 2. Okay. Same deal. 66. Again, same question. Okay, same thing here again. Okay, same deal. Let's just check that again. Square root of 40, 2, square root of 5, up. See that? I made a mistake somewhere. Oh. Two square root of 10. There we go. See, that's why you always check. Same problem. That one worked out nicely. Let's see. Alright, if this line M is perpendicular to both of these two lines, then it also has to be perpendicular to the plane that contains those two lines. So, 3. Let me see if I can pull out the card for you. It's card number 1. Right? If a line is perpendicular to each of two intersecting lines at their point of intersection, then the line is perpendicular to the plane determined by them. See that? That's the one. In fact, it's this one for the next few. Lines J and K intersect at point P. Line M is drawn, so it's perpendicular to them. Which statement is correct? Again, it's card 1, right? Which is that picture. So it's perpendicular to the plane containing lines J and K. 72. In plane P lies lines M and N intersect at point A. If line K is perpendicular to line M and line N at point A, then line K is perpendicular to plane P. It's card 1. Same deal. This one's the same thing also. Same deal, card 1. Okay? So if M and N intersect at point A, line K is perpendicular to both lines M and N, which they must be true. That means line K must be perpendicular to plane containing M and N. Lines A and B intersect at point P. Line C passes through P and is perpendicular to the plane containing lines A and B. So that means it also must be perpendicular to lines A and B. So line C is perpendicular to both lines A and line B. Now this one's a little different. This is the second card. Okay. Point P is on line M. What is the total number of planes that are perpendicular to line M and pass through point P? Through a given point, there passes one and only one plane perpendicular to a given line. And that's the picture. So, 1. Point P lies on line M. Point P is also included in distinct planes Q, R, S, and T. At most, how many of these planes could be perpendicular to line M? According to card 2, only one. Through a given point P on a plane, how many lines can be drawn that are perpendicular to that plane? This is almost the same exact thing, alright, but it's just said like backwards. See, through a given point, there passes one and only one line perpendicular to a given plane. This is card 3, and it's the same picture. So, 1. Same thing again. Point A is not contained in plane B. How many lines can be drawn through point A that will be perpendicular to plane B? 1. Card 3. There it is. Point A lies in plane B. How many lines can be drawn perpendicular to plane B through point A? 1. Card 3. There it is. Uh-oh. Aha. If two different lines are perpendicular to the same plane, they are coplanar. Yeah, they must lie in the same plane. That's the fourth one. Two lines perpendicular to the same plane are coplanar. See? See these two lines? If they're perpendicular to this blue plane, that means they must lie in a plane of their own, which is the yellow plane. Then we have let's see. This one down here at the bottom should say Tools of Geometry, Planes, G4 080. Yeah, we're probably going to have to change this one a little bit. If line AB is contained in plane P and line AB is perpendicular to plane R, which statement is true? Then we know that plane P must be perpendicular to plane R. So let's see what card that is. It's this one. It's card 5. Two planes are perpendicular to each other if and only if one plane contains a line perpendicular to the second plane. There's the picture. Okay, so at the bottom you need to change this GG3 to GG5. Okay, let's see. As shown in the diagram below, FJ is contained in plane R, and BC and DE are contained in plane S. Okay, and they all intersect at A. Which fact is not sufficient to show that planes R and S are perpendicular? So, all of them would prove that it's perpendicular except for DE being perpendicular to FJ. Let's see, is that here? It's probably here in a different way. Let's see. FA and DE, that's it right there. If FA is perpendicular to DE, that does not mean that the two planes are perpendicular. The planes would have to be perpendicular this way. And if these two lines are perpendicular this way, then this plane can still turn, and this could still be perpendicular as that plane moves and is no longer perpendicular. So it's choice 1. And what card would that be? I don't know. That's like a combination of cards, so I don't think that's any particular card. But give me 1 sec, and I'll tell you which card it's closest to. Let's see. This was number 82. This would be GG5 again. So change GG3 at the bottom to GG5. 83. Line K is perpendicular to plane P at point T. Okay, which statement is true? Well, this one has to do with card 7. If a line is perpendicular to a plane, then every plane containing the line is perpendicular to the given plane. There's the picture. So, all planes that intersect plane P will pass through T. No. Any plane containing line K is perpendicular to plane P. That's it. Line AB is perpendicular to plane AEFG. That's this one up here. AB is perpendicular to this plane. Which plane must be perpendicular to plane AEFG? Well, either of the two planes that contain AB, which would either be this one on the side or the one in the front. So let's see what choice. We have A, B, C, E. That's it. Or B, C, D, H. Nope. C, D, F, E. Nope. H, D, F, J. H, D, F, G. Nope. It's choice 1. Okay. Now, this one has to do with card 8. In three-dimensional space, two planes are parallel and a third plane intersects both of the parallel planes. The intersection of the planes is a... If a plane intersects two parallel planes, then the intersection is two parallel lines. See? There they are. A pair of parallel lines. Plane A is parallel to plane B. Plane C intersects plane A in line M and intersects plane B in line N. Lines M and N are parallel, right? Same deal. Card number 8, okay? '87 has to do with card 9. Line K is drawn so that it is perpendicular to two distinct planes, P and R. What must be true about planes P and R? If two planes are perpendicular to the same line, they are parallel. Okay? So planes P and R are parallel. A support beam between the floor and ceiling of a house forms a 90-degree angle with the floor. The builder wants to make sure that the floor and ceiling are parallel. Which angle should the support beam form with the ceiling? So if we have a ceiling and a floor, the support beam should form 90-degree angles with both, and the ceiling and the floor should be parallel. So 90 degrees. '89. Plane R is perpendicular to line K and plane D is perpendicular to line K. Which statement is correct? That means the planes must be parallel. That's still card 9. Right? Still card 9. 2. Two distinct planes A and B. Two distinct planes A and B are perpendicular to line C. Then which statement is true? That means the two planes must be parallel. That again is card 9. And I think we have one more of these, which should be the same deal. Or maybe not. EF intersects PQ and R. PQR, EF has intersected them. If EF is perpendicular to P and R, which statement must be true? That means P and R must be parallel. And that is based on card 9. Okay? Let's see. 92. Now we're getting into prisms. The figure in the diagram below is a triangular prism. Which statement must be true? DE congruent to AB? No. AD congruent to BC? No. AD parallel to CE? Yes, AD and CE will be parallel. Okay? That is on a card. Not sure which one. Let me see. Here it is. Card 11. The lateral edges in a prism are congruent and parallel. See? Lateral edges are congruent and parallel. The diagram below shows a right pentagonal prism. Which statement is always true? BC parallel to ED? No. FG parallel to CD? No. FJ parallel to IH? Nope. GB parallel to HC? GB parallel to HC. Yes, because of the same deal. Lateral edges are parallel and congruent. Card number 11. Okay? 4. Whoops. 4. Almost there. Rectangular prism. Which pair of edges are segments of lines that are coplanar? Okay. AB and DH? No. AB goes this way and DH goes this way. Not that. AE and DC? AE? No. DC is that way. AE is this way. BC and EH? Up. There's BC going this way and there's EH. You can imagine a plane at an angle, right, connecting those two lines or containing those two lines. So, and then 4 is CG and EF. CG and EF. They go in, one's going up and down and one's going front to back. So no, that's just choice 3. 95. Rectangular solid. Which statement must be true? EH and BC are coplanar. EH and BC. Yep, they're coplanar. You can imagine a plane containing both of those lines. They're parallel. Okay, and any two parallel lines can be drawn in the same plane. Let's just look at the other choices, FG and AB. Look, they go in opposite directions, or different directions. EH and AD, same deal. Ooh, wait a second. Oh, no, it says EH and AD are skew, and they're not. Okay? Skew, by the way, means like this. One going in one direction and one somewhere else going in another direction. Okay? Like that or something. But they're not crossing or anything like that. And they're not touching. So, and then same thing, FG and CG are skew. That's not true either. Okay? They're perpendicular, FG and CG. And EH and AD are parallel. So they would be coplanar too, but it doesn't say coplanar. And 96, the lateral faces of a regular pyramid are composed of congruent isosceles triangles. Let's see which one that is. Hold on a sec. That's problem 96. Whoa, hang on. 96. That would be GG13. So, hang on. I want you to write at the bottom of 96, tools of geometry, solids, GG13 096. Okay? And that's it for today.